postulates. A postulate, or also called an axiom, is a statement that is accepted as true without needing any proof. So we have a few postulates, things that we accept as true. These are just numbered in your textbook, so that's why you'll see these numbers here. So through any 2 points, there is exactly one line. This is really kind of by the definition of a line. Through any 3 non-collinear points, so not in a line, there is exactly one plane, and a line contains at least 2 points in it. At the very least, we know it has to have 2 points in it. A plane contains at least 3 non-collinear points, kind of similar to the ones we started with. If 2 points lie in a plane, then the entire line containing those points also lies in a plane. If 2 lines intersect, then their intersection is exactly 1 point. If 2 planes intersect, then their intersection is a line. Okay, so these are all things we just assume are true. We're going to talk a lot about proofs for the rest of this chapter. So a proof is a logical argument in which each statement you make is supported by a statement that is accepted as true. It's supported by either a postulate or something we've proved. So deductive arguments are a logical chain of statements that link the given statement with a reason. So we don't want to just say something's true. We want to be able to know it's true. So we have to have either something called a theorem, which we're going to come up to in a little bit, or I guess in another section or two, or it might be a postulate, but it needs to be something that we know is allowed. So in this class, we're only going to be writing 2-column proofs, though you'll see in your textbook, sometimes there's a flow proof or a paragraph proof, and these just aren't the proofs we are going to talk about. So even if you flip through your textbook and you see those, you can ignore those. We are going to stick to doing 2-column proofs. Okay, so in order to write a proof, we want to first list all of the given information, and the reason that we know it is because it is given to us. Then we're going to create a deductive argument to form a logical chain of statements linking the given information to what you're actually trying to prove at the end. You'll justify each statement with a reason, and that reason could be a definition, it could be a property, a postulate, or a theorem, kind of like the Pythagorean theorem. It's a rule we know is true. And then we're going to state at the very end what we've proven and how we were allowed to make that proof. So here's our algebraic proofs, and that's what we're going to start with today. Our algebraic proofs, we have some rules. We know the addition property of equality, where we can add something to both sides. Same goes for subtraction, multiplication, and division, as long as I do it to both sides of the equation. We have something called the reflexive property, and you want to think like a reflection in a mirror. The left is exactly the same as what's on the right of that equal sign. So A equals A, 2 equals 2, 4 equals 4. I have to write the same thing twice. Symmetric allows me to reverse the order. That's how at the end of an equation, when we solve for x and we get x on the right-hand side instead, we're allowed to flip that around and still say that x equals. The transitive property is then taking kind of 3 pieces of information. So I know that A is equal to B. I know that B is equal to C. So if both A and C are equal to B, I can assume they're equal to each other. For example, if I say A is equal to 2, and I say 2 is equal to C, then that means both A and C have to be 2, so they're equal to each other. Substitution is where we're allowed to replace something. Maybe we're solving in an equation. And then the distributive property, obviously, we're just literally going to distribute. Okay, so let's take a look at some algebraic proofs. So what we want to do is make sure we are showing every step. What's a little bit different about this is we're going to try to do it all in one line at a time. So instead of writing like +2 underneath, we're going to write +2 in a line. Okay? So the first thing we're going to do when we look at this is our given, right? This is the given equation to us. What we want to do is first, to clean this up, is to distribute. So we will multiply 2 times 5 and get 10. We'll do 2 times -3a. We'll do -4 times a. And we'll do -4 times 7. And that's going to equal 92. And what allowed us to do that was the distributive property. All right, the next thing that I am going to do is I am going to clean this up. So I'm saying negative 6a and negative 4a is going to make negative 10a. And I have 10 plus 28, and that's going to give us, 10 minus 28. Right, negative 4 times positive 7. And that's going to give us negative 18 is equal to 92. Now, yes, I combined like terms here, but that's not a rule. What actually happened here is that I substituted the original expression with this one. So this is actually going to be substitution. Okay. All right, so the next thing that I am going to do is that I want to add 18 to both sides. So I have that negative 10a minus 18 is equal to 92. Nothing's really changed there, but I am going to add 18 to both sides. And what allows me to do that is the addition property of equality. There's only 2 D's. There we go. Okay, the addition property of equality. Now I'm going to clean that up. So I have, let's see, that is negative 10a is going to equal 110. Again, anytime that I'm like combining like terms or just cleaning up, we're going to say that is substitution. All right, the next thing that I want to do is division. Now, I know there's an urge to just draw the line underneath and write the number, but we want to write this in a row, so it has to be its own step. So now we are going to divide by negative 10. And when we divide by negative 10 on both sides, that is the division property of equality. Okay. And then last but not least, we're going to clean this up. So when I divide, I get a on the left, and that's going to equal on the right negative 11. And anytime I clean up, that is substitution. So yes, I know that took longer. This isn't a trick for solving anything. This is reasoning as to why I'm allowed to solve the problem the way I am. All right, so let's take a look at these, and we're going to state the property that is going to justify each statement. So if we have 2 times x plus 1 equals 10, then 2x plus 2 equals 10. This is the distributive property. If we take a look at B, if 5 equals y, then y equals 5. So when I switch the order around, that is symmetric. If negative 5x plus 3 equals 17, then negative 5x plus 3 minus 3 equals 17 minus 3. That is the subtraction property of equality. All right, so let's take a look at a few more proofs, and we're going to kind of have our columns drawn out for us here. All right, so we have this statement. It says, if negative 5 times x plus 4 is equal to 70, then x is equal to negative 18. So what we are starting with, our hypothesis or a given, is that negative 5 times x plus 4 is equal to 70. We want to prove that then, if that's true, x equals negative 18. So we're proving x equals negative 18. All right, so in our 2-column proof, we always put the given statement first. So given is right here. And the reason for that is that it was given to us. It is given to be a true statement. I don't need to go searching for an answer. All right, so if I take a look, what happened from step 1 to step 2, it appears that we have distributed. So in order to get to the next step, we have distributed. This is the distributive property. So we multiplied those two terms by negative 5. Okay, now it looks like we are adding this 20 to both sides. This is the addition property of equality. All right, next it looks like we cleaned up. Whenever we clean up, that is substitution. Number 5, it looks like we're dividing on both sides, so that is the division property of equality. And lastly, it looks like we've proven what we needed to. And the last thing we had done there was clean it up, so that's substitution. So here is my given at the top. Here is what I'm trying to prove at the very end. And there are all the steps and reasons why I'm allowed to do them in between. That's what a two-column proof looks like. Let's take a look at the next one. So again, we have an if-then statement. Our if is going to tell us what we are given. So that is our 2x minus 13 is equal to negative 5. And we are proving x equals 4. All right, so the first thing we want to do is make sure we put the given in there. So that's 2x minus 13 is equal to negative 5. And the reason we can say that is that it was given to us. We are hoping at the very end to prove that x is equal to 4. So that should be our very last statement here. Now we need to figure out what are the steps in between. So if I take a look, 2x minus 13, how do I start to solve for x? It looks like I need x by itself. So I'm going to add 13 to both sides first. So we have 2x minus 13. We have negative 5. So we're going to add 13 to both sides. And that is the addition property of equality. All right, so we're going to clean that up. So when we clean that up, the 13's cancel. That gives me 2x is going to equal 8. And when we clean up, we call that substitution. Okay. The next thing that we're going to do is divide by 2. So when we divide by 2 on both sides, that is the division property of equality. And 2x divided by 2 is x. 8 divided by 2 is 4. That means that we do have what we needed to prove. And the reason we moved from step 4 to 5 is through substitution. Anytime we're cleaning up, it is substitution. Okay. Last one. So if 5x plus 1 divided by 2 minus 8 equals 0, then x equals 3. Again, our if is our given. Our then is what we are proving. So we have 5x plus 1 divided by 2 minus 8 equals 0, and that is because it is given to us. We don't have to do anything special. We want to prove that x is equal to 3, so we can put that in our last space here. X is equal to 3. All right, so the next thing we want to do is to add 8 to both sides. All right, so when we add 8 to both sides, that is the addition property of equality. And then we're going to clean that up with substitution. So we have 5x plus 1 divided by 2 is going to equal 8, and that is by substitution. The next thing we're going to do is get rid of that 2 in the denominator. We can do that by multiplying. So we're going to multiply both sides by 2. And that would be the multiplication property of equality. When we clean that up, we're going to get 5x plus 1 is equal to 16. And that's substitution. Anytime I clean up, it's substitution. The next thing we're going to do is to take that 5x plus 1, and we are going to subtract 1 from both sides. All right, so when we subtract 1 from both sides, stick to another color, we'll subtract 1 from both sides. That is going to be the subtraction property of equality. Okay, clean it up. So we get 5x is equal to 15. And last but not least, I'm going to take that 5x and that 15, and I need to divide them by 5 to get 3. So that is going to be, whoops, I forgot our substitution, right? When we cleaned up, it was substitution. And then when I divide by 5, that is the division property of equality. And lastly, we would clean up by